Hello guys, welcome back to the channel. Today we're going to solve this Leetcode question, which is find the pivot integer. And in this question we're given a positive integer n, and we need to find the pivot integer x such that the sum of all elements between 1 and x inclusively equal to the sum of the elements sum of all elements between x and n. And return the pivot integer x. If no such integer exists, we need to return -1, and it is guaranteed that there will be at most one pivot index for the given input. There can only be at most one pivot element. Okay. So any given input, we have only one input, or we don't have any. I'm sorry. We will either have one pivot integer or we don't have any pivot integer. That's what they are saying in this last line. So in this question, what they are saying is we are basically given an n, and we need to find a point between from 1 to n. We need to find a point where it gets divided equally. Here the sum from 1 to 6 is 21, and the sum from 6 to 8 is again 21. So these two are these two are equal, right? So they are getting divided at number 6. So number 6 is the pivot integer. Let's look at this example. It's the same example. Like when n equals to 8, we have 1 2 3 4 5 6 7 8. We'll write the numbers like this, and we need to find the point at where the left sum and the right sum of the pivot index are same. If you observe carefully, the sum from 1 2 3 4 5 6 is 21, and the sum from 6 7 8 is also 21. So these two are getting equal at point 6, right? Since 6 is the common element between these two, so 6 is the answer. 6 is the answer. So here we need to take care of one thing. Here the x is inclusive in both the paths. Means 6 should be included in the left part, as well as the 6 should be also included in the right part as well. Right? We need to take care of this. And when n equals to 1, this is another example. The left sum till 1 is also 1. The right sum from 1 to the end is also 1, right? So 1 is the pivot. So 1 is the answer. If you only take 4, there will be no pivot, because the sum till 1 is 1, and the remaining sum is 1 plus 2 plus 3 plus 4, which is 7 8 10, right? And the sum till 2 is 1 plus 2 3, and the remaining sum is this 2 plus 3 5, 5 plus 4 9. This is 3 and this is 9. And when you take this, 1 plus 2 plus 3 is 3 plus 2 5 6, and this sum is 7, right? And when you take everything, the sum will be 10 and this will be 4. So there is no pivot when n equals to 4. So we have to return -1. So let's see how are we going to solve this question. So if you observe carefully, so what I'll do is, initially I'll assume this is my pivot element. So I'll have a left sum. I'll have two variables, which is left sum and right sum. So this left sum starts from 1 and goes till pivot element. This left sum starts from 1 to pivot, and this right sum starts from pivot and it goes till n, right? So I will find this left sum and I will find this right sum for every value. For every value, when my pivot is 1, I'll find the left sum and I'll find the right sum. And if these two are equal, then it is my pivot element, right? So then I'll return this. Suppose if you look at this example, when my pivot is 1, the left sum is till this point, right? 1. And the right sum is 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8. So these two are not equal. Then in the second iteration, my pivot is this point. So 1 plus 2, which is 3. And the right sum is 2 plus 3 plus 4 plus until 8. So these two are also not equal. And like this, the loop will continue till, when my pivot becomes 6, the left sum will be 21 and the right sum will also be also 21. So then then we will return 6, right, as the answer. So let's look at the code of this. So what I'll do is initially I'll take a pivot for int I equals to 1. I'm sorry, my pivot starts from 1, I less than pivot less than or equals to n, and pivot plus plus. I'll assume the every element has pivot. So right now I'll take left sum equals to 0, and my ith pointer goes from 1 to pivot, right? I plus plus, and left sum less equals to I, and I'll take a right sum equals to 0, and my another pointer starts from pivot and goes till n, and I plus plus right sum plus equals to I, right? If my left sum is equals to right sum, I'll just return my pivot, right? And after looping all these values, if I don't find any pivot, I'll just return -1, right? So let's try to submit this. It's getting accepted, guys, but look at this. The runtime is very slow. Let's look at the time and space complexity. The time complexity is we're basically using this goes from 1 to n, so which is order of n into this loop goes from 1 to pivot, which is half, and this loop goes from this half to n, right? So it is inside the loop also we're again going n times. So our time complexity is order of n square. The space complexity is, since we are not using any extra space, the space complexity is order of 1. So this is not an efficient approach, right? So in order to make this as efficient, we can do one thing. What we can do is initially I'm going to find the sum of the entire array, right? So why am I going to do that? I'll explain you. Just a second. So now we have this example, right? Now what I'll do is initially I'll find the sum of the entire array, which is total. Let's say the total is 42. The sum of these values is 42. So when I'm going from left to right, suppose I'm at this point. When I'm going from left to right, I'll keep on adding these values. Suppose at this point my left sum is 6, right? 1 plus 2 plus 3, which is 6. Now from here, if I want to get the sum of these values, what can I do? I know that the sum of the everything is 42, right? And I know that the sum of these three values is 6, right? So I can get the sum of these values by reducing 42 minus 6, right? So what I'm doing is to get the right sum, this is the right sum, right? To get the right sum, I'll do total minus left. So then I will get the right, RIGHT, right? So at this point I have left sum and right sum, but we need to take care of one thing. We need to add the pivot for both the left and the right? So I also need to add the pivot value for this as well. So using this, in order of one time, I'm getting the left sum, I'm getting the right sum, and I can just compare these two, right? If my left is equals to right I'll just pivot, pivot, right? So this is what I'm going to do. Basically, I'll start pivot from here, and while I'm going, I'll keep on adding the left value, and for every value, I'm going to find the right value using this formula, and I'm going to check these, and if both are equal, then I'll return the pivot, and when my pointer exceeds the all the array values, I'll just return -1. This is what I'm going to do. So let's look at the code. So initially my left sum is 0, right? So my pivot equals to 1 and pivot is less than or equals to n and pivot plus plus, right? And my left sum plus equals to pivot. Now I need to get the right sum, right? In order to get the right sum, we have this formula. Total minus left plus pivot. Oh, we need to find the total, right? So int total equals to 0. You can find the total by looping through each and every value, but we can also use a mathematical formula which is n into n plus 1 by 2, right? Sum of n elements. N into n plus 1 by 2. This will give us the total, and we have the formula total minus left sum plus pivot, right? We have left sum and we have right sum. If left sum is equals to right sum, I'll just return pivot, or else I'll just return minus 1 at the end, right? Let's run this. It should work fine. Look at this, guys. The runtime is only 1 millisecond since we are using only one loop. So let's look at the time and space complexity right now. We can easily tell the time complexity, right? Since we are using only one loop and inside the loop we are only using constant operations, the time complexity is order of n and we are not using any space complexity, right? So it is order of 1. So that's it, guys, for this video. If you like the video, then like the video. Thank you.